Hello everyone, welcome to our mathematics channel 360 degree mathematics. In today's video we will discuss sum of n terms of an GP. In the previous video we discussed nth term of GP and the general idea of GP. Now the formula of sum of n terms of an GP, first we will discuss the terms of a GP are generally A, AR, AR square, AR cube and dot 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 A r to the power n minus 1, where A equals to first term, R equals to common ratio. R may be greater than 1 or less than 1. Now the structures of formula of sum of n terms of a GP will be different. That is Sn equals to A r to the power n minus 1 by r minus 1 when r greater than 1. R may be greater than 1 or less than 1. In the case of r greater than 1, we get Sn equals to A r to the power n minus 1 by r minus 1. And the second version of the formula is Sn equals to A 1 minus r to the power n by 1 minus r when r less than 1. That is r may be half, 1 by 3, 1 by 4, 1 by 5. In this case we will use this formula. Sn equals to sum of n terms. Now we present the problems in favor of this formula. The sum of first question is this: the sum of first 6 terms of a GP is 9 times of the sum of its first 3 terms. Find the common ratio of GP. In this case, in the language of the problem, it is clear that S6, sum of 6 terms, is 9 into S3, that is 9 times of sum of 3 terms. Let A be the first term and R be the common ratio of GP. Here we consider R greater than 1 normally. If nothing is said in the problem, then we will consider R greater than 1. By formula we can write S6 equal to 9 S3. Now A into r to the power 6 minus 1 by r minus 1 equals to 9 into A r cube minus 1 by r minus 1 implies r to the power 6, this r minus 1 cancelled, A cancelled. R to the power 6 minus 1 equals to 9 r cube minus 1, and from this calculation we can present r to the power 6 by r cube minus r to the power 6 minus 1 by r cube minus 1 equals to 9, and by calculation we get r cube plus 1 equals to 9 and r cube equals to 8, that is r equals to 2. Here r to the power n, that is 3 is odd number and hence the 8 is positive 8, therefore r is only plus 2, therefore common ratio is r equals to 2. Now we start the second problem. How many terms of the series 1 plus 3 plus 9 plus 27 plus dot 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 must be taken so that the sum is 9841. In this case sum is given 9841, series is given 1, 3, 9, 27. From the series we can find out first term and common ratio, and Sn is given. Therefore we have to find out the n, how many terms. The question is how many terms, that is n is to be find out. Given the GP 1, 3, 9, 27 dot dot dot, sum of this GP is 1 plus 3 plus 9 plus 27 plus dot dot dot. Now let n terms be required to make a sum 9841. Now you can write Sn equals to A r to the power n minus 1 by r minus 1. In this case, as 3 by 1 equals to 9 by 3 equals to 27 by 9 equals to 3, that is r equals to 3 and A equals to 1. Here put A equals to 1, 3 to the power n minus 1 by 3 minus 1. By presenting 9841 equals to 3 to the power n minus 1 by 2, by calculation we get n equals 3 to the power n equals to 3 to the power 9, that is n equals to 9. Therefore required number of terms is 9 to make a sum 9841 of the GP 1, 3, 9, 27 dot dot dot. Now we present the third problem. In favor of the sum formula. if S1, S2, S3 be respectively the sums of n, 2n and 3n terms of a GP, prove that S1 in bracket S3 minus S2 equals to S2 minus S1 whole square. By question, Sn equals to S1, S2n equals to S2, S3n equals to S3. Let A be the first term and R be the common ratio. Whenever we apply S1, then we apply the sum formula, that is A R to the power n minus 1 by R minus 1. S2 equals to A R to the power 2n minus 1 by R minus 1. S3 equal to A R to the power 3n minus 1 by R minus 1. Now we take left hand side S1, S3 minus S2. S1 A R to the power n minus 1 by R minus 1. S3 A R to the power 3n minus 1 by R minus 1. S2 A R to the power 2n minus 1 by R minus 1. By taking LCM, we get in the denominator R minus 1. In the outside of the bracket A R to the power n minus 1 by R minus 1. And in the numerator we get this. By cancellation of 1 plus 1 minus 1, we get A R to the power 3n minus R to the power 2n by R minus 1. Now A R to the power n minus 1 by R minus 1, taking A common in outside of the bracket, R to the power 2n R to the power n minus 1 by R minus 1, that is A square, A square, and R to the power 2n equal to R to the power n minus 1 whole square by R minus 1 whole square. This is number 1 relation. If I consider RHS, then we get S2 minus S1 whole square. By putting S2 and S1 here, we get S square R to the power 2n minus 1 minus R to the power n plus 1 minus 1 cancel out, and R to the power 2n R to the power 2n R to the power n minus 1 whole square by R minus 1 whole square. That is, this becomes S square R to the power 2n R to the power n minus 1 whole square by R minus 1 whole square. This is number 2. The relation 1 and relation 2 are exactly equal. Therefore, LHS equal to RHS. Hence, we can write S1 S3 minus S2 equal to S2 minus S1 whole square. That is proved. Now we start the concept of geometric mean. This is the third concept. In our analysis, in the last video, we presented first concept, nth term. In today's video, we present second concept, sum of n terms, and now we start third concept, geometric mean of GP. If three terms A, B, C are in GP, then B is called geometric mean between A and C. Suppose 2, 10, 50 are three terms in GP, then 10 is the geometric mean between 2 and 50, because 10 is here in middle of 2 and 50. This is GP because of 2 into 5 10, 10 into 5 50. In a more extended sense, if more than 3 terms are in GP, then terms between two extremes are called the geometric means of the extreme terms. Thus, we can explain this as follows: 2, 6, 18, 54, 162, 486, G1, G2, G3, G4, 2, 6, 18, 54, 162, 486. Here 2 and 486 are the two extreme terms, and there are 4 geometric means between two extremes 2 and 486. Theoretically, if A, B, C are in GP, then it becomes B by A equals to C by B, that is B square equal to AC, that is B equals to plus minus root over AC, and B is the geometric mean. Now we present a problem of GM in favor of this geometric mean theory and concept. Insert 6 geometric means between 56 and minus 7 by 16. Let the 6 geometric means be G1, G2, G3, G4, G5, G6, and the whole structure becomes 56, G1, G2, G3, G4, G5, G6, and last term is minus 7 by 16. Now the first term a 56 T8 minus 7 by 16, let R be the common ratio and T8 equals to a r to the power 8 minus 1 equals to minus 7 by 16 equals to 56 into r to the power 7. Now r to the power 7 equals to minus 7 by 16 into 56, and it becomes r to the power 7 equals to minus 1 by 128 equals to minus 1 by 2 whole to the power 7. Therefore r equals to minus half. Now G1 equals to a into r, that is 56 into minus half, that is minus 28. G2 equals to a r square equals to 56 into minus half a square, that is 14. G3 equals to a r cube, that is 56 into minus half cube minus 7, and in this way G6 up to G6 we get minus 7 by 8. Therefore the complete GP becomes 56 minus 28 plus 14 minus 7 plus 7 by 2 minus 7 by 4 7 by 8 and minus 7 by 16. 56 and minus 7 by 16 are two extreme terms, and in between all these 6 terms are GM, geometric means. Now we present the second question in favor of geometric mean. If x to the power n plus 1 y to the power n plus 1 by x to the power n plus y to the power n is geometric mean of x and y, that is this term is in between x and y, find n. Given the GP structure is x to the power n plus 1 plus y to the power n plus 1 by x to the power n plus y to the power n comma y, these two are extreme terms, this is middle term, this is GM. Therefore we can write x to the power n plus 1 plus y to the power n plus 1 by x to the power n plus y to the power n equal to root xy, and just crossing this we get x to the power n plus 1 plus y to the power n plus 1 equals to x to the power n plus y to the power n into xy whole to the power half. By calculation lastly we get x to the power n plus half in bracket root x minus root y equals to y to the power n plus half in bracket root x minus root y. Hence x not equal to y, therefore we can cancel this part and this part, and we get x to the power n plus half equal to y to the power n plus half by arranging x by y whole to the power n plus half equals to 1. 1 means x by y whole to the power 0. Here we apply the formula of indices. If two bases are equal, then two powers must be equal, that is n plus half equal to 0 and equals to minus half. Therefore for n equals to minus half, x to the power n plus 1 plus y to the power n plus 1 by x to the power n plus y to the power n becomes the geometric mean between x and y. Today we discussed 3 problems on sum of terms, n terms of geometric progression, and 2 important problems of geometric means. Here this is all about today. Please keep watching our channel for new videos and updates. Thank you all for watching this video.